take a nice, deep breath. The air fills your lungs, and it feels completely normal. Then all of a sudden, you just stop breathing. For the first few seconds, you might not even feel like anything is wrong. You're holding your breath. No big deal, right? But inside your body, a silent, frantic battle for survival has already kicked off. Your oxygen levels start to plummet, and your body immediately goes into crisis mode. Within seconds, the concentration of oxygen in your blood begins to drop. This is a state called hypoxia. Your brain, the biggest oxygen consumer in your body, is the first to feel the impact. It needs about 20% of your total oxygen intake to function properly. Without it, things get messy, fast. The first 30 seconds are surprisingly calm on the outside. But inside, your body is scrambling. The carotid bodies in your neck, which are special sensors, detect the drop in oxygen and scream at your brainstem to get you breathing again. Your heart rate might actually slow down for a moment, a reflex to conserve oxygen, before it starts pounding to pump what little oxygenated blood is left to your vital organs. After about a minute without air, things get serious. Your skin might start to turn a bluish color, a condition called cyanosis, especially around your lips and fingertips. This is because the hemoglobin in your red blood cells, which turns bright red when carrying oxygen, becomes darker when it's deoxygenated. At the same time, your brain cells are starting to panic. You'll feel confused, dizzy, and your judgment will become severely impaired. This is because the neurons can't produce enough energy, called ATP, without oxygen. They start to malfunction, leading to a breakdown in communication across your brain. You might experience tunnel vision, or even brief euphoric sensations as your brain's delicate chemistry goes haywire. By the 2-minute mark, your body is in full-blown emergency mode. Your brain is so desperate for oxygen that it triggers widespread vasodilation, forcing blood vessels to widen to increase blood flow. But it's a losing battle. Carbon dioxide levels are building up, making your blood more acidic. This metabolic acidosis starts to damage cells and tissues throughout your body. Somewhere between 3 to 5 minutes, you'll likely lose consciousness. This is your brain's last-ditch effort to conserve energy. It's shutting down all non-essential functions. But by now, the damage is becoming irreversible. Brain cells begin to die, a process called apoptosis, or programmed cell death. The areas responsible for memory and higher cognitive functions, like the hippocampus and cerebral cortex, are hit the hardest. If you go more than 5 minutes without oxygen, the chances of severe, permanent brain damage become extremely high. The chain of command inside your body has completely collapsed. The brainstem, which controls basic life functions like your heartbeat and breathing reflex, begins to fail. Your heart may start beating erratically and will eventually stop altogether. From a single moment of holding your breath to a complete systemic collapse in just a few minutes, the absence of oxygen reveals just how fragile our existence truly is. It's a stark reminder of the constant, invisible work our bodies do every second to keep us alive. Thanks for watching, and remember to hit that subscribe button for more deep dives into how your body works. See you next time. Every breath you take sends oxygen into your lungs. Inside the lungs are millions of tiny air sacs called alveoli. These sacs are surrounded by microscopic blood vessels. Here, oxygen crosses into your bloodstream and attaches to a special protein inside red blood cells called hemoglobin. Hemoglobin acts like a delivery truck. It carries oxygen through your arteries to every organ in your body. Your heart pumps this oxygen-rich blood nearly 100,000 times a day. But when breathing stops, this delivery system begins to fail. In the first 10 seconds without oxygen, your brain notices something is wrong. The brain is extremely demanding. Even though it makes up only 2% of your body weight, it consumes about 20% of your oxygen supply. Without oxygen, brain cells cannot produce energy. Electrical signals between neurons begin to slow. This is why people often lose consciousness after about 10 seconds of oxygen deprivation. But the real damage is just beginning. Ever held your breath underwater, trying to see how long you could last? Or maybe you've tried one of those viral breath-holding challenges. What's actually happening inside your body when you stop breathing? It's not just about a lack of oxygen like you might think. It's a fascinating chemical story, and it all starts with carbon dioxide. So here's the deal. Every moment of every day, your cells are busy at work, creating energy to keep you alive. A byproduct of this process is carbon dioxide, or CO2. Normally, you just breathe it out without a second thought. Your blood picks it up, carries it to your lungs, and poof, it's gone. But when you hold your breath, that CO2 has nowhere to go. It starts to build up in your bloodstream. Now, this is where the science gets really cool. When CO2 dissolves in your blood, it reacts with water to form something called carbonic acid. Yes, acid. As more and more CO2 piles up, more carbonic acid is produced, which makes your blood more acidic. Your body is incredibly sensitive to this change. A specialized part of your brain, the brainstem, acts like a master controller. It has sensors that are constantly monitoring the pH level of your blood. When these sensors detect that your blood is becoming even slightly too acidic, they sound the alarm. They send an urgent, powerful signal to your diaphragm and rib muscles, screaming, "Breathe, now!" This is that overwhelming, almost painful urge to gasp for air you feel after holding your breath for a while. It's not so much a cry for oxygen, as it is a desperate command to get rid of the excess carbon dioxide and restore your blood's chemical balance. If you were to ignore these signals, the situation would escalate. Your diaphragm would start to contract uncontrollably, causing those involuntary spasms or hiccups you might feel. This is your body's last-ditch effort to force you to exhale the CO2. Eventually, your brain's powerful survival instincts would take over, and you'd be forced to breathe, whether you wanted to or not. It's a brilliant, built-in safety mechanism. So the next time you hold your breath, remember what's happening. It's a dramatic race against time, driven by the buildup of carbon dioxide and your brain's relentless mission to keep your body's internal chemistry in perfect harmony. It's a powerful reminder of how intricate and amazing our bodies truly are. Thanks for watching, and if you found this interesting, be sure to hit that like button and subscribe for more deep dives into the science of you. See you next time. Have you ever wondered what happens inside your brain when it's starved of oxygen? It's a race against time, a cellular emergency. Without oxygen, our brain cells, the neurons, can't produce the energy they need to function. Within just a few minutes, this energy crisis triggers a toxic chain reaction. The first to fall are the most vulnerable areas, like the hippocampus, which is crucial for memory. The cells begin to swell and release harmful chemicals, creating a domino effect that damages neighboring neurons. This process, called excitotoxicity, leads to widespread cell death. Understanding this delicate balance highlights just how vital every single breath is for our brain survival. Thanks for watching, and don't forget to subscribe for more fascinating science. Have you ever held your breath for as long as you could? What actually happens in your brain when it's starved of oxygen? Our brain is a real energy hog, using up about 20% of the body's total oxygen, even though it only makes up 2% of our body weight. So when that oxygen supply gets cut off, things start to go haywire pretty quickly. Within just a few seconds, you'd start to feel dizzy and confused. This is your brain's first cry for help. The cells in your brain, called neurons, need a constant stream of oxygen to produce energy. Without it, they can't fire properly, leading to impaired judgment and a loss of coordination. Think of it like a city losing power. First the lights flicker, then everything starts to shut down. After about a minute, the real damage begins. Neurons start to die. Unlike other cells in our body, most neurons can't regenerate. Once they're gone for good. This is when vision might start to blur and you could lose consciousness. Your brain is desperately trying to conserve energy for the most critical functions, like breathing and heart rate. But it's a losing battle. If oxygen deprivation continues for 3 to 5 minutes, the damage begins. Did you know your brain is in a race against time without oxygen? After just 5 to 6 minutes, severe and often permanent brain damage can occur. Unlike other cells, brain neurons don't regenerate easily. Once they're gone, they're usually gone for good, which can impact memory, movement, and even consciousness forever. Fortunately, the body can sometimes be saved if oxygen returns quickly. CPR and artificial ventilation can restore oxygen to the brain. Doctors can also cool the body slightly to slow brain metabolism. Lower temperature reduces the brain's oxygen demand, giving doctors more time to repair the damage. In some rare cases, people have survived surprisingly long periods without oxygen thanks to rapid medical intervention. Here's something incredible. Your body contains about 25 trillion red blood cells. Each one carries oxygen molecules through a network of blood vessels that stretches over 60,000 miles. That's more than twice the circumference of Earth. And this entire system works automatically, every second of your life. If you want to see what actually happens inside your brain during a stroke, subscribe to InnerBody Lab, and I'll see you in the next video.